Welcome back, everyone. Yesterday we learned about a lot of properties for parallelograms. Today we are going to be talking about their properties of their diagonals. So we have a few theorems about the diagonals of parallelograms. The first one says that the diagonals bisect each other. What that means is that, for example, on this parallelogram, BE would have to be congruent to ED, and AE is congruent to EC. The diagonals are BD and AC, and they cut each other in half. We also know that each diagonal separates the parallelogram into two congruent triangles. So, for example, triangle ABC must be congruent to triangle CDA. This triangle is congruent to this triangle. We could also look at that the other way around, and we could prove that if we needed to. Let's look at example 2. How can we use this in a problem? It says, if QRST is a parallelogram, find the value of all the variables x, y, and z. So let's look for x first. I see 5x here. It is on the side QT. I know that opposite sides in a parallelogram have to be congruent, so I know that QT has to be equal to RS. So I get 5x equals 27. That means that x is 27 over 5, or if we use that as a decimal, we would get 5.4. Next, let's look at y. I see that 2y minus 5 is the length of this piece of the diagonal, and y plus 4 is the other half of the diagonal. I say half because I know diagonals split each other into congruent pieces, so TP must be congruent to PR. So I know 2y minus 5 must be equal to y plus 4. I can solve that by subtracting y on both sides and adding 5 on both sides. Finally, I'm looking for the value of z. I see z is this angle TSP. Since I have parallel lines, I know that opposite sides of a parallelogram are parallel. I know that alternate interior angles are congruent. So that means that angle TSP has to be congruent to angle PQR. That means that 3z is equal to 33, meaning z equals 11. All right, go ahead and try the practice problem. Here are the correct answers. Next, we're going to look at a parallelogram on the coordinate plane. It says, determine the coordinates of the intersection of the diagonals of a parallelogram FGHJ with these vertices. Go ahead and plot the vertices and label them. That's the first step. Next, since we are trying to find the coordinates of the intersection of the diagonals, I know that these diagonals are going to cut each other in half. So wherever they meet is the midpoint of FH, and it's also the midpoint of JG. I only need to find one of the midpoints. I'm going to find the midpoint of GJ. You could choose FH if you wanted. So in order to find midpoint, I put the formula here to remind you of it. Remember, it's just the averages. So we're going to average the x values. It doesn't matter which one you put first. And we're going to average the y values. That gives us 0 over 2 and 1 over 2. That simplifies to 0, 1/2, or 0, 0.5. Whether you want that written as a decimal or a fraction does not matter. But what that means is that our two diagonals will intersect at this point here, 0, 1/2. Now, since I found the midpoint of GJ, what I could do to check my answer is find the midpoint of FH. it should give me the same answer, 0, 1/2. Remember to write this answer with parentheses around it because it is a coordinate point. Go ahead and try to find the coordinates of the intersection of the other problem. Here's the correct answer. -1, 2.5, and I showed you how you could check that work as well. It doesn't matter whether you choose RT or SU. You can pick which one you want and use the other to check. All right, we will eventually have to do a proof here, so let's go ahead and try this one. It says we are given that ABDG is a parallelogram. Let's check that out. That's this here. This is a parallelogram, so we know all the properties of parallelograms apply. We also know that AF is congruent to CF. I marked that. And we want to prove that angle BDG is congruent to angle C. So I marked that in yellow here. I'm going to go ahead and erase it now because we should not mark something that we do not know in our image. Let's see if we can fill this in. We are given that ABDG is a parallelogram. We can use the symbol here to make it easier. Since the opposite angles in a parallelogram are congruent, let's look at this. Which opposite angles are going to help us here? Is it going to be more helpful to use these opposite angles, angle A and angle BDG, or angle AGD and DBA? Well, since angle BDG is something that we need in our answer, let's go ahead and put that in as one of our angles here. I know angle BDG is congruent to angle A because they're opposite angles in this parallelogram. Okay, we are also given that. What else have we not used from the given? We haven't yet said anything about segment AF is congruent to segment CF. By the isosceles triangle theorem, ITT, let's look at that. Those two sides are a part of this triangle, AFC. Remember, isosceles triangle theorem says the angles across from the congruent sides must be congruent. So that gives me angle A is congruent to angle C. Now pay attention closely to what we have. We have BDG is congruent to angle A, and angle A is congruent to angle C. Look also at what we're trying to get. Angle BDG is congruent to angle C. Notice that we have that here, and we have angle A matching up in the middle. So we can use the transitive property of congruence to say our answer, angle BDG is congruent to angle C. Okay, there's another proof for you to try. Here's one correct answer. Remember, there's multiple ways to prove things, so this may not be the only correct answer. And finally, I want you to reflect on this. The following is a false statement. I want you to provide a counterexample. So remember, that's an example of why this is false. It says, if two parallelograms have congruent corresponding sides, then the parallelograms are congruent. So see if you can find two parallelograms that have congruent corresponding sides, but the parallelograms are not congruent. That's what you're trying to find an example of. Find two parallelograms that have congruent corresponding sides, but the parallelograms are not congruent. See if you can find an example. Tomorrow we will learn more about how to figure out whether a quadrilateral is a parallelogram or not. And we will be able to tell, just given a shape with four sides, is it a parallelogram or is it not? So I'll look forward to talking to you then.